Hi everyone. We're going to look at another type of word problem with fractions, and those are motion problems, which we studied once before. Let's just review motion problems. Grace's family drove out to the country at an average speed of 30 miles per hour, and they returned over the same road at the rate of 40 miles per hour. If they were on the road for 7 hours, how far is the drive out to the country? Well, the way we used to do it is we remembered that in any motion problem, the important formula to remember is that rate times time equals distance. And we used to always set up an equation in terms of the distance, and the key was either the rate or the time. So if we go back and review this, we would let x equal the number of hours it took Grace's family to drive to the country. And because the total number of hours were 7, we could let 7 minus x equal the number of hours it took Grace's family to drive back. So that was our key. And to represent the distance going out, well, the distance to go out is the same as the distance coming back. So the distance would be the rate times the time would be the distance going out equals the rate times the time. And these two distances were the same, and we would solve for x. So let's do that quickly. So if we solve for this, we get 30x equals 280 minus 40x. We get 70x equals 280, and x is 4 hours. So it took Grace's family 4 hours to drive out to the country and 3 hours to come back. And let's not forget that they asked us how far is the drive out to the country. So what we have to do is we take 4 times 30, which would give us the time times the rate, is 120 miles drive to the country. Now, another way to do this problem is using fractions. Well, if rate times time is equal to distance, time is equal to distance divided by the rate. So another way to do this problem using fractions is because we don't know how far the drive is out to the country, we'll let x equal, let x equal the distance, the number of miles to the country. So the time going can be represented as the distance, which is x, divided by the rate, which is 30. And the time back can be represented as the distance, which is x, divided by the rate, which is 40. And we know that the total time for the trip is 7 hours. So our equation can be x over 30 plus x over 40 equals 7. And if we proceed to solve this time, x would give us the distance directly. So we would multiply both sides by the least common denominator, which in this case would be 120. And let's see if we get the same answer. So when we distribute on this side, we get 4x plus 3x equals 840. 7x equals 840, and x is indeed 120. And that would give us the number of miles out into the country directly. So with fractions, sometimes you could get the answer directly. Let's take a look at another problem. Plane, oops. All right, let's take a look at problem number 3. Dan rode his bicycle 12 miles into the country. His bicycle broke down and he had to walk back. His rate on the bicycle was 4 times as fast as his rate on foot. The round trip took 5 hours. Find Dan's rate of walking. Okay, so let's just make a little chart here. Here we have to, okay, so let's write down bicycle. So he goes on his bicycle and he goes walking. And we're going to look at distance divided by rate equals time. Okay, we want to fill those in. Now, the question is, what information do we know here? Dan rode his bicycle 12 miles into the country. His bicycle broke down and he had to walk back. So it's implied here that he rode 12 miles and he walked back 12 miles. So his rate on the bicycle was 4 times as fast as his rate on foot. So if we let x equal his rate walking, 4x would equal his rate on the bicycle. So let's write down our key. Let x equal the rate walking, and let 4x equal the rate riding. So the time algebraically would be 12 divided by 4x, which we could simplify into 3 over x, and 12 over x for the time walking. And we know that the round trip was 5 hours. So our equation would be 3 over x plus 12 over x is equal to 5. This is easy enough to solve. We could add the fractions because they have a common denominator. We have 15 over x equals 5. We can cross multiply or multiply each side by x. We get 15 equals 5x and x equals 3. So Dan's rate of walking was 3 miles per hour. And that would answer the question. All right, let's take a look at number 8. Ella took a small plane and a car to leave Kansas City and head for Minneapolis, 450 miles away. The plane flies 3 times faster than the car can drive and arrives 6 hours ahead of the car. Find how many hours it takes the car to complete the trip. Okay, so in this problem, it may be a little bit confusing the way it's worded, but Ella has 2 options to go to Minneapolis, either by plane or by car. So we have to consider these separately. So we'll make a little chart, plane and car. And we have distance divided by the rate equals time. So let's try it. So the distance, whether she goes by plane or car, is 450 miles. But it does say that the plane flies 3 times faster than the car can drive. So the plane's rate's 3x and the car's rate's x. Let's write that key. Let x equal the car's rate and let 3x equal the plane's rate. So the time by plane would be 450 divided by 3x. And the time by car would simply be 450 over x. Now, there's a little catch. It says that the plane flies 3 times faster than the car can drive and arrives 6 hours ahead of the car. So if we take a look at the car's time, which is 450 over x, and the plane's time, which is 450 over 3x, notice that the plane would travel less time than the car. So to make it balanced, we would have to add 6 on this side or subtract 6 on the other side. Okay, so to solve this, we could do many things, but let's simplify this fraction to 150 over x plus 6. We could subtract 150 over x on each side, and we get 300 over x equals 6. If we cross multiply, we get 300 equals 6x, and x equals 5. So the car's rate is, oh, I'm sorry, it should be 50. That didn't make sense. So the car's rate is 50 miles per hour, and the plane's rate is 150 miles per hour, which makes sense. But it says find how many hours it takes the car to complete the trip. So the car completes the trip in 450 divided by 50 hours, which means in 9 hours in this case. Whereas the plane would take 450 divided by 150 hours, and that would give you 3 hours. And that would answer that particular question. Okay, let's take a look at another one. Let's take a look at 16. Nathaniel travels 108 miles and finds that he could have made the journey in 4.5 hours. 4.5 hours less had he traveled 2 miles per hour faster. At what rate did Nathaniel travel? So let's see. Okay, so Nathaniel has 2 journeys, and notice that his time would have been 4.5 hours less if he had traveled 2 miles per hour faster. So let x equal Nathaniel's rate, and let x plus 2 equal Nathaniel's faster rate. Okay, so let's say we have the regular trip and the faster trip. So the distance is 108. The rates are x and x plus 2. So the time here is 108 divided by x and 108 divided by x plus 2. So his time on his regular trip is 108 over x. His time on his faster trip is 108 over x plus 2. Now let's remember which number would be smaller. Well, the time that's smaller would be the faster trip. Or the bigger the denominator, the smaller the number. So we would have to add 4.5 on this side to make it equal to the time on his regular trip. Or we could have subtracted 4.5 on the other side. Just remember which trip had more time and reason it that way, where to add the number. All right, I'll leave it up to you to solve. So when we solve this, we multiply each side by the least common denominator, which is the product x times x plus 2. And when we multiply, the x's divide through here, and the x plus 2 divides here, but we have to distribute this to the 4.5. So distributing and collecting terms, we end up with this quadratic. 0 equals 4.5x squared plus 9x minus 216. I multiplied each side by 10 and divided everything by 45. And this quadratic here comes out to be factorable into x plus 8 times x minus 6. We set each factor to 0, and we reject the negative 8, and we take x equals 6. So to answer the question, at what rate did Nathaniel travel? Nathaniel traveled at 6 miles per hour. So let's write that down. Okay, and that takes care of that question. Now, in number 17, we have Claire drives to work at 50 miles per hour and arrives 1 minute late. Claire drives to work at 60 miles per hour and arrives 5 minutes early. How far from work does Claire live? All right. Well, here again, we'll let x equal the distance in miles to Claire's work. All right. So we have the slow trip and the fast trip. And we don't know the distance, so let's call that x. Whether she's traveling slowly or quickly, the distance is still x. The rate, well, when she travels slowly, it's 50 miles per hour, and when she travels quickly, it's 60 miles per hour. So the time would be x over 50 at a slower rate and x over 60 at a faster rate. But let's read the question now. They don't really tell us about the total time or the relationship between the times. It does say that Claire drives to work at 50 miles per hour and arrives 1 minute late. So if she's the time that she takes to travel slowly, she loses 1 minute. So we could represent that as 1 minute over 60 minutes. So that would be the time traveling at the slow rate. If she travels quickly, she arrives 5 minutes early. So if we take the time it takes her to drive quickly, we would add 5 over 60 on this side. So if we think about it, this side time should be the same as this side's time. And let's go through it again. So if she travels quickly, she has more time to spare, and that's 5 minutes. So we could add 5 minutes there. But if she travels slowly, she doesn't have time to spare. She lost time, so we subtract a minute. Now, if we start solving this, well, this one is pretty easy to solve. We could multiply everything by 60 if you'd like. So let's solve it quickly. But I think it's easier to solve it this way. We could combine the fractions on this side because they're both over 60 and get x plus 5 over 60. And if we add 1 over 60 to the right side, we get x plus 6 over 60. We can cross multiply and solve, and our answer is that x is 30. So the distance to Claire's work is 30 miles. All right, let's do one more. All right, this is number 12, but I saved it because I think it's the trickiest of all. Eva wants to bring some brownies to Grandma's house, which is 6 miles away. Eva rides her bike for the first 5 miles and walks the last mile, and the trip takes her 45 minutes. Had she walked all 6 miles, the trip would have taken her twice as long. Find Eva's biking speed and her walking speed. All right. Now, we're asked for many things here, so let's take it slowly one more time. So Eva takes her bicycle, so we have biking and walking. I'll put B and W for that. Okay. And Grandma's house is 6 miles away. So we know that she traveled 6 miles to go to Grandma's house. But hold on a minute. Eva rides her bike for the first 5 miles. So the first 5 miles, she rides her bike and walks the last mile. So she walks 1 mile one way. Her rate is not known here. And we're not given any relationship between the rates of her biking and walking. So let's call those x and y. So let x equal the rate on her bike, and let y equal the rate walking. So the time here would be 5 over x and 1 over y. And we know that the total time of the trip was 45 minutes. So we could add 5 over x plus 1 over y is equal to 45 over 60 because we're representing the rate as miles per hour. So let's just write that down. Okay, that's one equation. And that could be simplified into 5 over x plus 1 over y is equal to 3/4. All right, but we need an equation to solve for x or y. Had she walked all 6 miles, so if she walked 6 miles, the trip would have taken her twice as long. So if the trip would have taken her twice as long, the time for her trip would have been 90 minutes, which is 90 over 60, or 3/2. But her rate of walking is still y. So we could say that her time, which is 3/2, is equal to her walking distance, which is 6, divided by her rate walking, which is y. And this equation will enable us to solve for y. So if we cross multiply, we get 3y equals 12 and y equals 4. So her rate walking is 4 miles per hour, which is reasonable. Now we can substitute that over here, and we get 5 over x plus 1 over y equals 3/4, but we could put the 4 in for y. Oh wait, this is plus 1/4 equals 3/4. Subtract 1/4, we get 2/4 or 1/2. Cross multiply, and x is 10. So the rate walking is 4 miles per hour, and the rate on her bike is 10 miles per hour. So this problem had a little twist. It had 2 unknowns to solve for because they weren't directly given, but we were able to solve one to get the other. Okay, that takes care of our motion problem with fractions. Have a wonderful day.